Using slope to find parallel lines. When you draw two lines on the same graph, there are three conditions that are possible. One condition would be that they are parallel. Notice that parallel lines, they're slanted the same amount. That means they have the same slope. Lines could intersect. That means that they cross each other at a specific point. They'll have different slopes. You could also have lines that are the exact same line. They fall on the same points. Example 1. Given the equations of two lines, y equals negative 4x minus 6 and y equals negative 4x plus 5, determine if the lines are parallel, intersecting, or if they're the same line. To determine if the lines are parallel, you must compare the slopes and the y-intercept. So the first thing we need to do is find out what is our slope and what is our y-intercept. Our equations are in the form y equals mx plus b. This is slope-intercept form. Slope is our m. B is our y-intercept. So let's look at our first equation. Y equals negative 4x minus 6. M is negative 4. B is negative 6. For our second equation, M is negative 4 and B is positive 5. Notice that they have the same slope and different y-intercepts. This means that our lines are parallel. Example 2. Write an equation for the line that is parallel to y equals negative 5x minus 3 and passes through the point 4, negative 5. This example asks for an equation of a line passing through a specific point that is parallel to a given line. To be parallel, the lines must have the same slope. Since you have slope and a point, you can get an equation with the point-slope formula. Our point-slope formula is y minus y1 equals m times the quantity of x minus x1. We can locate our slope in our equation. Our slope is negative 5. We have our x1 and our y1 to plug into the equation. Y minus y1, which is negative 5, equals slope, negative 5, times the quantity, x minus x1, which is 4. Now we can simplify this. Y minus negative 5 is the same thing as y plus 5 when you add the opposite. Next, I need to distribute negative 5 to my x and negative 4 to minus 4. Negative 5 times x is negative 5x. Negative 5 times minus 4 is positive 20. I need to put my equation in slope-intercept form, so I'm going to solve for y by subtracting 5 from both sides. Now the y is by itself. Y equals negative 5x plus 15. The equation y equals negative 5x plus 15 is parallel to y equals negative 5x minus 3, and it passes through the point 4, negative 5. Some of us choose to use slope-intercept form rather than point-slope formula. That is completely okay. It's up to you which one you'd like to use. This is our second method. Instead of using our point-slope formula, we're going to use y equals mx plus b to write our equation that's parallel to y equals negative 5x minus 3 and goes to the point for negative 5. We still know that our slope has to be parallel, and our slope is negative 5. We have our x and we have our y to plug in. So negative 5 equals negative 5 times 4 plus b. Negative 5 times 4 is negative 20. To solve for b, I'll add 20 to both sides. When I do this, b will equal 15. Now I can write my equation by plugging in the slope and the y-intercept. My slope is negative 5. My y-intercept is 15. Y equals negative 5x plus 15. Notice that this answer is the same equation if you work it using point-slope formula. Example 3. In the graph below, two lines are represented. Using the given points, determine if the two lines are parallel. To be parallel, the lines need the same slope with different y-intercepts. You can see from the graph that the y-intercepts are different. Line A has a y-intercept of 2. Line B has a y-intercept of negative 6. Use the 2 points from each line to determine the slope and compare them. We're going to use slope formula, which is y2 minus y1 over x2 minus x1. So for line A, we'll use the 2 points given to us. Negative 3, 5, and 4, negative 2, and plug this into our formula. y2 minus y1 over x2 minus x1. Negative 2 minus 5 is negative 7. 4 minus negative 3 is positive 7. This means that my slope is negative 1. I can confirm this by looking at my graph and using rise over run. Rise down, seven, and right, 7. Now let's find the slope of line B. The 2 points that they give us are negative 4, negative 2, and 0, negative 6. y2 minus y1 over x2 minus x1. 6 minus negative 2 is negative 4. 0 minus negative 4 is positive 4. So my slope is negative 1. I can confirm by using rise over run. I'm going to rise down 4 and run right 4. Compare the slopes. Negative 1 for line A and negative 1 for line B. Since they are equal, both conditions have been met. The lines are parallel. Example 4. Line P is shown on the grid below. Determine if a line with the equation y equals 3/2 x plus 2/3 is parallel to line P. For the lines to be parallel, the slopes must be the same and the y-intercepts must be the same. Step 1. Identify the slope of the equation given in the problem. The equation is given in slope-intercept form, so find m. The equation that they give us is y equals 3/2 x plus 2/3. Slope-intercept form is y equals mx plus b. I can identify my slope by finding m. m equals 3/2. Step 2. Find the slope of line P. Since we are given a grid, we can easily count up and over to find the slope. We'll count up 2 and right 3. So rise 2, run 3. Is the slope of the line on the graph the same as the slope of the line in the problem? 3/2, 2/3. No, it is not. So the lines cannot be parallel. Sometimes parallel lines are referred to as lines with no point of intersection. And you may see the equations in standard form. To make the comparison easier, put the equations in slope-intercept form. Example 5. These two equations represent lines in a coordinate plane. 3x plus y equals -6 and 6x plus 2y equals 10. Do the lines intersect? First, let's put our equations in slope-intercept form. Slope-intercept form is y equals mx plus b. So for both equations, we're going to solve for y. Our first equation is 3x plus y equals -6. I need to solve for y by moving my 3x. I'll subtract it since it's a positive 3x. That way our 3x's will cancel out, and I'm just left with y. -6 minus 3x can be written as -3x minus 6. Now our second equation. Subtract 6x from both sides. 2y equals -6x plus 10. Our y still is not by itself. I need to move the 2. We'll divide every single term by 2. Y equals -6 divided by 2 is -3x. 10 divided by 2 is +5. Now we can determine what our slope and our y-intercept of each line is. Our slope is m. Our y-intercept is b. For our first equation, m equals -3 and b equals -6. For our second equation, m equals -3 and our y-intercept is 5. Compare the slope of the two equations. They are the same. Look at the y-intercepts. They are different. These lines are parallel and do not intersect. To determine if lines are parallel, remember, put the equations in slope-intercept form. Check to see if the slopes are the same. Make sure the y-intercepts are different. Practice 1. The graph below shows several lines with points identified on each of the lines. Each line on the graph will match a parallel line in the list on the left. Match the equations of the lines given on the left to a parallel line on the graph. Press pause. When you're ready, press play. Practice 2. Answer the questions below. Press pause. When you're ready for the answers, press play. When you're checking your answers and comparing your work to my work, remember that I've used point-slope formula. You can also plug into y equals mx plus b if that's the way you like to work the problems.